Hi friends, welcome to my coating lecture series. In this session, I'll be explaining about the volume solids because most of the people have got some doubt with volume solids and weight solids. First of all, we should be able to find out the difference between the volume solids and weight solids. In fact, this volume solid is more useful to justify the true cost of the paints. So it should not be confused with the weight solids. Volume solid is nothing but how much area a paint will cover the surface, whereas weight solid is the weight of non-volatile ingredients. Now let me focus more on the volume solids. See, the paint volume solids, it is a very useful parameter to justify true cost of the paints. It is also useful to obtain the paint coverage in square feet per liter or square meter per liter. Thereby we can determine the quality of the paint and the painting also. So the volume solid should be that is understood that it is what is left after the paint dries. I have explained here with a simple illustration. See, that is paint consists of pigment percentage is 20%, then binder is 20%, this vehicle is equal to 59% and additives 1%. So likewise we have got some wet paint. So once the paint is dried, after all, the vehicle part, which is nothing but the thinner, the volatile thinner, in the case of aqueous paints, that is water. So the volatile thinner will go off, isn't it? So the remaining will be only pigment and binder, and that is the volume solids of the paint. In this case, we have illustrated as 40% volume solid. So likewise, it should be. And this volume solid is a very useful parameter, and also we have got different volume solids for different types of paint. For example, the sealer type of paints, so it has the volume solids between 10% and 25%. In the case of architectural finishes, we have got the range between 35 and 45%. In the case of industrial enamels, probably that is, it may start with 25% and 45%, that is 25 to 45%. And in the case of 2-pack epoxy, it may even go up to 80% from 40%. Then in the case of 2-pack polyurethane, it may contain 30 to 45%. One thing you have to note down, that is low volatile content paints will have higher volume solids. Let us now discuss about the coating thickness. Actually, this coating thickness principles depend on the characteristics of coating and substrate, and based on the different types of the natures of the coating as well as the nature of the substrate. That is, we have got different techniques of measuring the coating thickness. We can apply magnetic induction principle, then eddy current, ultrasonics, and we can make use of this X-ray fluorescence, and we can directly measure using that is calipers or micrometer, but accuracy may not be there as far as calipers and micrometers are concerned. And initially we can have some visual examinations and cross-section analysis. We can use microscopes also for this purpose. Now, the dry film thickness, actually that is the term used for coating thickness. This dry film thickness means that is what is the coating thickness after the paint is dried, and this is the ratio between the weight of the solid material and the volume of the solid material, or this can also be obtained from the ratio between the wet film thickness and the solid content ratio. Sometimes it can be calculated from volume of wet coating divided by the specific gravity of the coating material. Now the density is equal to weight by volume. Here we have got the substrate over which we are given the coating of certain thickness. Is it not? Hiding power of pigment. So using appropriate pigment we can have good opacity, that is called hiding power. So we can make use of this good quality pigment with high opacity and also with a high solid content of binder, we can have a very good quality paint. Let me consider the substrate here. So over which we are given a coating of certain thickness. Density is equal to weight by volume, and density is equal to weight divided by area into thickness, because volume is nothing but area into thickness. So we can make use of this equation to obtain the thickness value. So thickness is equal to weight divided by area into density. So coating thickness can be illustrated as the coating weight material, that is coating material weight divided by coating area into density of the coating material. And usually this coating thickness is interpreted in terms of that is the units, mils and micrometer. 1 mil is equal to 1,000th of the inch, that is 0.001 inch. And 1 mil can also be equated to micrometer as 25.4. And based on the industries, both units are used. Let me explain about the determination of non-volatile materials. Let us take a flat metal lid. Its weight can be accurately measured as W1, that is the tare weight. Then we have to take the coating weight material. In the case of a paint, you have to take paint, a small quantity, and the tare plus this weight of the material is taken as W2. Then it should be kept for say about 3 hours at 120 degrees Celsius in a oven. Then after that you have to take and let it cool to the room temperature, and we have to weigh once again the lid plus the dried weight film. So that is noted as W3. NVM, that is non-volatile material percentage, is given by this equation. W3 minus W1 divided by W2 minus W1 into 100. So from this we can declare the solid content. This solid content is nothing but non-volatile material, and this can be either given as a percentage or as a ratio also. Now let us discuss about the different methods of determining the coating thickness. Wet film thickness gauge. This is one of the most straightforward method that involves using a wet film thickness gauge. This tool is used when the paint is still wet. We have to place a gauge into the wet paint, and it will give you a reading of the thickness. Make sure to follow the manufacturer's instructions for accurate measurements. Second is dry film thickness gauge. Once the paint has dried, a dry film thickness gauge can be used. This tool measures the thickness of the coating after it has cured. Similar to the wet film thickness gauge, we have to follow the manufacturer's guidelines for accurate readings. Then let us proceed to cross-sectional analysis. This is another method, and it involves taking a cross-sectional sample of the coated material, and we can examine it under a microscope. This method is more complex and it may require some specialized equipment and expertise. Now let us proceed with the ultrasonic thickness measurement of coating thickness. Ultrasonic thickness gauges can be used to measure coating thickness. The gauge sends ultrasonic waves through the coating, and the time it takes for the waves to bounce back provides information about the thickness. This method is commonly used for measuring the thickness of metal coatings, but may be applicable to other materials also. For example, we can apply this equation. We know that is a formula S is equal to V into T. This is used in physics, particularly motion. S represents displacement, whereas V the velocity, T is time. Now we can replace this displacement by thickness. Okay, so thickness is equal to the velocity of the ultrasonic sound. Are able to follow? So the ultrasonic wave into time taken. Are able to follow? So we have to send the ultrasonic signals from the top and it gets bounced from the substrate. And what is the time taken for this? And based on that, we can calculate the distance traveled by this ultrasonic wave. That is nothing but the thickness. Actually, the thickness, we can call it 2D because it has to come and hit the substrate. So 2D into the velocity into time. So in that case, D is the thickness. So V into T divided by 2. So we know the velocity of our ultrasonic wave and we can monitor the time taken for this. So when you multiply V and T, then by 2 we are able to get the thickness. So likewise we can measure the thickness of coating using ultrasonic principle. Then let us proceed to micrometer or calipers. In fact, this is for a rough estimate only. We can use a micrometer or caliper to measure the thickness of the coating at various points on the surface. But we should keep it in mind that this method may not be as accurate as other specialized tools. Eddy current gauges can also be used to measure coating thickness. They work by inducing eddy currents in the conductive substrate, if it is present, and measuring the change in the electromagnetic field caused by the coating. In fact, this method is non-destructive and can be effective for insulated materials. So, especially the paint applied on insulated materials and the coating of such paint can be measured using this eddy current gauge. We can adopt another principle called X-ray fluorescence. X-ray fluorescence analyzers can be used for measuring the coating thickness, especially on metal substrates. So this XRF instruments emit X-rays and measure the fluorescence emitted by the material. So this method is also a non-destructive and it can provide accurate readings.